Well, thank you. Pleasure to be here. And yes, so my title is Effective Use of Clickers in the Classroom, but maybe Best Practices is a better title, because how do you define effectiveness? I don't have hard data to show you about my use. We'll talk about education research out there and with this approach. Let me see if I can get this going. But what I've done is implement best practices as far as I see it. So that's, I think, a more fair title. And I just want to say I've been doing this for many years, actually, since the late 90s. We'll get into that, not always with clickers. I'll mention that too. But this is the first time I'm talking about it. So this is the first time I've made a presentation about what I do. Speak with my colleagues often, and I have a lot of personal ideas about it. But so I apologize if a slide is out of order or things need to be improved. Well, just let me know. This is a new talk in and of itself. So, let's see. All right, so maybe this. Let's do it like this. So what I'm going to talk to you about. There's actually not a lot of iClickers in the start. Assessment, teaching, and learning. The ideas of teaching approaches. And then we'll talk about the large lecture and what we're trying to do in lectures about conceptual change. And then we'll talk about a pedagogy called peer instruction. Maybe you've heard of that. If not, I'll explain that. And then finally, we'll talk about using clickers. So this is not really so much a talk about clickers. They're the means to the end, but in and of themselves, not the whole pedagogy. So we'll start with the idea of assessment. This is your typical assessment loop. You may have seen this at different levels. How well are the students learning? You gather data, interpret the data, and adjust your teaching approach in what they say close the loop and get back to where you are. And we have to do this at an institutional level for our bachelor's, master's, and PhD programs. This is on a sort of a yearly cycle. And then we talk about how we did in class today. You ask your colleague, how was class? You've already begun assessment just talking about it. So we do it informally. Well, what we're talking about here is formalizing this sort of assessment loop within a class period. And so these folks, Black and Williams, looked at assessment and classroom learning, and if there's a way that you can question and get feedback and update your approach within the class, then you get large gains in learning. But that's, I don't want to say common sense, but if you're a teacher and you have 3 or 4 students, this is what you do when you teach. You talk, you find out what they know, and from what you learn, you teach some more. So this is all pretty basic. So the idea of the assessment loop, but what we want to do is build that into a large lecture. And if I look at the ideal, there's a lot on here. I apologize, you may not read it all, but the classroom experience, again, this is ideal without the clickers in a way. The teacher efforts, you formulate a problem, the heart of the lesson, and you want each student to respond and try and get some conversation going, and you hope the students have full participation, support of each other, and you want their ideas to change or grow or develop, and you want them to self-regulate their learning. And so this middle section is how that happens, and this is where if you're a teacher in a small classroom or one-on-one, you can do this on your own. And the idea is we're going to have something for the large lecture that allows us to provide our representations that enable thinking. So this is our projection system. Have student responses. And this is where our clickers come in, but it doesn't have to be clickers. And then somehow collect those responses and display them publicly so the students can see what each other's thinking. When you get everybody responding, you get full participation instead of the one person raising their hand in a small class. And so there's these connections between these ideas, and then the idea is once you have this information, it could feed back. So far it's still pretty typical. This is the ideal situation in terms of teaching and the relationship we have with the students. Now we get to the large lecture, okay, when you have, and large we have here 100, 200 students. I have 240 for introductory physics, but you could still do this with 20 students. You know, as soon as you get over a handful, the dynamics change. And the dynamics between 20 and 200, they're only different in that you don't notice all the other students reading the paper or not listening, but they're not answering, just the same as if there's 20 or buying in. And so this suppressed student interaction, we want to get rid of that. We want the active buy-in, the give and take with the professor, find learning opportunities. And we're going to use technology to create this interaction, and we want to measure its effect on learning. And the early work, education research, originated in the physics classrooms with this technique. And before clickers, we used flashcards to get the feedback. So in the late 90s, I had students make just cards, take a piece of paper with a number 1, 2, 3, and 4, and they would hold them up for when I had the multiple choice questions on. Now I didn't get quantitative information, didn't get attendance information, but I could see if everyone had the same number up or not. And so this is when we started to develop this technique. And then, of course, clickers really, made this much easier. And in fact, I'll show you later, I'll mention now, the clickers were also developed by physicists at Illinois. So you can blame us for as much of the problem as well as the progress. So the pedagogy predates the technology. And so I want to talk about the pedagogy, how we teach and what we do differently in a large lecture. And basically how I implement the peer instruction here at USC, because there's a lot of pieces of it, and we can talk about the different pieces and implement what we can. And then I hope that we are improving the critical thinking by this new technique, a core value of USC. So, one word about conceptual change and why I think this is a great approach. Misconceptions about scientific ideas remain after students take a class. Common sense is often wrong, but seldom discarded. There's education research. I've met McDermott and others which have shown this, where if you just tell a student something, they might memorize it, they might regurgitate it, but they don't feel it, they don't believe it. But they use examples of rolling balls down a tilted hill. Which way would they go? Their gut tells them one thing, but physics says another. And until they discover it, and so they did a lot with discovery science, until they discover it, they don't change their ideas, even if you tell them what they're thinking is wrong. And we know that there's a lot of folks who've gone through our science classes that still don't have good scientific common sense. And so the idea is that this peer instruction is pioneered by Mazur from Harvard, generate this active large lecture experience and work on conceptual change. And there's been documented improved student outcomes, and here's one of the references, the physics teacher, and American Journal of Physics, that they describe their gains. And I will show you those gains in a minute. So let me tell you a little bit more about what peer instruction is. We question the students and get their responses and display them, and then hopefully we can adapt the lesson plan in response to the student feedback. So, and there's a book about this. There's a website. So this is sort of a mini industry these days. And the key aspects are we actively engage the students in the lecture courses, so this is different than just sitting in the dark looking at the PowerPoint. And we do that by interspersing our lecture with short conceptual questions. And there's a collaborative learning strategy. The students are encouraged to help each other. This is where peer instruction comes in. That's for the title. After I pose a question, the students talk, and I walk around. I walk up and down the aisles, and I talk to groups, subgroups at a time. Usually one question one side of the room and another question the other side. And you hear them talking and discussing and trying to figure out the questions. And so, and the idea is that they're learning it for the first time, so they don't have the same mental schemas that I do, and things have fallen into place in a certain way, and I've rearranged them. They're coming at it the first time. And so when one gets it, they may have a better understanding of why their peer doesn't understand, because they have the same viewpoint. Where as a professor, some things seem obvious to me which may not be connected exactly to that problem, but may be part of the reason the student doesn't get it. And so students on the same level can help each other. And so then the students, they vote with their clickers. Here's two very good summary articles about clickers in the classroom, not from physicists. One is from a biologist, and but they're both fairly recent and very good. And just another reminder, so it's the instructional approach, not the clickers, although the clickers have made it very much easier to implement this method. Here's the gains that were made. This is from 2001, so it's a little old paper, and 1996. And the bottom line is students seem to learn more and are happier. Okay, and I could say I've seen the happier part, and I feel like they're better prepared for some types of questions, but I don't have this kind of data. But this is educational research data. They use standardized tests as benchmarks or pre-test, post-test comparisons of traditional lecture versus the peer instruction method. And so this is a plot of your average MBT, that's mechanics baseline test, so that's a standard physics test. Comparing the traditional values here, which is these open circles, and so this solid line, and then the test, either the full or just the numerical part for year over year, how the students do better given peer instruction than in traditional lectures. And this is also data, and it's a funny number. It's this G value, which is the post-test minus the pre-test over the gap between the pre-test and 100%. So how much do you close the gap by? Okay. And this line here, the bottom line, is your average traditional lecture score, and this line is the average from your peer instruction. FCI is the Force Concepts Inventory, another standardized physics test. And it shows that here's your average, and you could do calculus-based or algebra-based, and you see gains in both. But they have more data in this paper over about a decade of gains and improvement each year. Obviously, they're getting better at the course as well, but it's also, you might say the students are learning twice as much, okay, in that the gap between the pre-test and 100% gets reduced by half or so when looking at the scores from peer instruction versus traditional lecture. And there's lots of other data, pre-test, most of it's pre-test, post-test sort of stuff. And the happiness comes to attitude improvement, also the surveys, questionnaires to students after the class is also documented with similar approaches. I have mixed feelings about surveys because a lot of students self-report that they read the textbook, and I always wonder about that. But this is, be that as it may, this is what we have to work with. And so given these seeming great gains, it was worth trying here. So let's go back to the lecture. So here's a block diagram of sort of how my lecture works. A brief lecture, about 10 minutes, so 3-4 slides. And on a standard lecture, whatever concept, ideas, diagrams, equations, words, pictures, definitions. And then I put up a question that is a concept test. It's a 5 question or 5 answer multiple choice question. And then the students get to vote. Now this is where they ring it. And then I can see how the answers are coming in. There is on the base station, there's a little box which shows me the percentage of answers coming in. So even before I show them, I can have an idea of how things are going. And if everyone gets it, so either they all know it or the question's too easy. Designing these questions is an art. As this has started in physics, there are a lot of libraries of good questions. A lot of the publishers provide clicker questions with their books these days on a website for resources for instructors. Some are okay, some are better than others, but we've amassed a collection, and you pick out the right ones. But if everyone gets it, well, then if there's just a few that don't understand, you just make some mention and you can move on to your next topic. But what's interesting is when the breakdown is slightly different. If the correct answer is less than 30%, so everybody bombed, now you have to stop and think, well, what did I not say correctly? What did I miss? Or are they just asleep? And so then you have to revisit that concept. You can go over the same slides, or as often, we build this in a lot of times to our lectures that, well, we're going to redo it the next class again, maybe better, maybe different. So the feedback, we like. It's nice if you can do it sometimes within a class, but if you have to redo it the next time, but you have some hard data now as where a problem is. And then what's the fun ones are when you sort of split the class 50-50. And then what I do is I'll close the voting, I'll show them their answers, and then we'll have more discussion. So what it is during the students voting, that's 2, 3, 4 minutes, 2 to 3 minutes, they can talk to each other, and I tell them they can talk, and they can tell their neighbor the answer, but if they do, they have to tell them why. So because I want discourse. And then after we see the answers, if we have to revote, I'll say, okay, now it's down to these two answers. Talk to your neighbor, convince them that you're right, or find out why you need to change your answer. And I'll show you one example of that. And so then you discuss it some more and revote, and hopefully you make some progress. Pretty clear? So here is the slide on the clickers and how they work. So here, just the simple one has A, B, C, D, E, F buttons, and it sends the signal to an RF receiver. And what it does is sends the answer and an ID number, and the students have to register their iClickers in a database on the website, and I think Blackboard, it's now integrated. I'm a relic now, I still use the website. I have to go figure out how Blackboard does it, which associates the name with the clicker ID, and you get it all in the computer, and so that's very nice. iClicker.com has a nice website, shows you where everything is, developed by physicists at the University of Illinois. So that's where this started. We used Quizdom clickers for a while, but we switched to iClickers for a number of reasons. Technically, they're simpler, they work better in lecture, but what was nice is that a lot of the campus was using them. So there were two products for a while, and that makes it cheaper. There's a nice used market. So I didn't feel guilty last semester requiring my students in the part 2 of the lecture to suddenly get it. I did not do part 1 because you can get them for $20 used, $10, $20. They're all around, and they come without numbers scratched off. We can figure out the ID number and whatnot. They make fancier versions now that are $30, $40 if the students. Well, there's two different versions. This is the old one, and I believe that's like $30 new and $20 used from the bookstore. And so you could get it even cheaper. There's this sort of student market. Yes, each one of these has a unique ID number. So, right. I think they wipe out their database each semester or something. And
you don't have to use the website.
Right.
I use it. You put a role of your student in, and you run an application. It says Ed Gatsby, click A and then click B, and it figures out from you clicking that B. And it goes through the whole role of your class. And after 5 minutes, everybody's registered. That's the in-class.
So yeah, there's a number of ways, right? So you can do it. You can do it in class. And the bookstore sells them. This. Yeah, you tell them you want to use iClickers. They will. And they'll send you a fancy instructor's remote and everything else. They'll come visit you over and over. Sure, because That's right. And if you have a big lecture, they just see lots more students using them. So they're very helpful, and it's really pretty easy to use. Any other comments, questions about clickers? So I'm hoping this is discussion. I don't have too many more slides. I have some, but then I was hoping we could have a discussion how this works. The grading scheme is also important. It's got to be a significant amount, but not too much. If you don't give enough credit, the students are disinterested. They don't care. They just click away. I've had that happen. And if it's too much, they're stressed out about each answer. We don't find out, the students are our friends. We don't find out how worried they are until we give them a test, okay, about grades. And every little thing matters. And so I've implemented this system here which takes some of the pressure off. That they need to get 70% of the questions right, or 70% score. Above that, then they get full credit, or this 15%. So I say, it's going to be 15% of their grade is their clicker score, but that includes attendance. So that's attendance and getting the questions right. So, but to get that full 15%, they only need a 70% to this Q score, and they get a half a point coming to class. Last semester, I did a full point coming to class, and that was too much. And they get a point for a correct answer for a question, and there's roughly 2 to 4 questions per class. So over the semester, that's roughly 100 questions, so that means they need 70 points to get full value. And if they get 20 points, roughly with perfect attendance, so maybe it's 17 or whatever, depending on your 35 lectures and however many you have. These are just rough numbers, okay? You basically need half right or a little more than half right for full credit. Okay, so I want them to answer, but I want them to be thinking and trying. I don't want them to be just worried about the right answer, okay? Because when they were just worried about the right answer and they were stressed out, they'd wait. Nobody would vote until one person was sure, and you could see it spread through the class. One person has the answer, and then the answer sort of spreads from that one person. And nobody would put it in until they were sure everyone else was. And this system seems to work well. I've used this for 2-3 semesters now, where it's a significant part of the grade, but it includes attendance, and it gives them a chance to miss a question and not worry about it, which is really important because my questions range from very easy to difficult, and I want them to work on the difficult ones without being stressed. And I had a reference, but I couldn't find it when I wanted it, but this has been studied as well, the effect of the grading scheme on the student participation. So question types. And here's where I think clickers really have helped my lecture. My lectures focused on theory and examples for numerical homework solutions, your typical lecture. Here's the derivation, here's a diagram, and here's a derivation of the formula, and here's a sample homework problem. Any questions? Go ahead, go do it. They learned formulas this way, but conceptual problems were considered trick questions. Because when you read a book and you understand the story, you're able to speak about it in words, not just the equations. But if I asked somebody a word question, what the heck was that? Where did that come from? But now, with this peer instruction approach, I can ask conceptual questions both in class and on exams. And it helps train the students to answer a question without needing an equation, which for me was terrific help because I want to ask students conceptual questions on exams, but if I don't train them how to answer a question, it's sort of unfair to ask them to, right? Because we give them homework and they're numerical solutions. And so the test has got a lot of problems like that, so we train them to answer numerical solutions, we test them on numerical solutions. So now I can train them conceptually as well. And so now it's fair, a little more fair, to test them in that regard. It's still a challenge, but since we're working on it in class, it becomes a good question. And this is also, beyond the physics classroom. It's how do you answer a multiple choice question? How do you answer a general question? And I have to work with them every time. Get out a piece of paper, kind of make a sketch, draw an equation. What do you know? Because oftentimes when the kids see a multiple choice question, they think they should do it in their head. If they don't need a formula, well, they should just know the answer, but that's not true. There's a process that I want them to go through. Can you eliminate answers? You know, the typical start for a multiple choice question, but how do you approach something that's, words and ideas? And so this is what we work on when I walk around up and down the aisles. This is what I'm working on with the students. How are you approaching this question? And here's my personal aside back to the reading. I'm of the opinion that conceptual change and learning come from reading and reflection. Okay, something we ask our students to do. There's a reading assignment for every lecture. I have every lecture mapped out and which chapter we're in and what they should read. And I haven't asked them. I don't want to know the answer if they read the book or even have the book. But a lot of time needs to be spent reading and reflecting. And I also work with them to try and have them read a textbook. Our physics textbooks are different now than they were 25 years ago. They're full color with so much going on. It's a very active page with not only just equations and words, but graphs and sidebars. And a lot of times the physics is in the picture. And they need to read a picture. Sit and look at it, not just glance at it and see an arrow pointing this way or a squiggly line, but digest it. And they're not used to that. And so these kind of questions allow me to bring that topic up. And so in physics we communicate with numbers, pictures, and words, and they're not used to this. These different representations of information. And so my questions come with these different challenges. Some examples that I'll talk about today, I'll just give us 3 examples that I've pulled from recent lectures. Common calculation error, conceptual understanding, and then one that was a learning experience for me. One I recently, we split the class and they were wrong and for a surprise reason for me. I'll explain that. So I learned something. And then it's neat, I haven't done it yet this year. You can do opinion polls, build coherence and shared understanding with each other. I want to ask them each their majors, and I haven't figured out the 5 out of the possibles that I could ask. I should look at my roles, but see, I know what they are, but they don't know who each other are. Okay, so but now they would, and on election day or that the day before November 2nd, the Monday class, I'll put up they can vote for president, stuff like that. So there is some fun stuff that they can do. Okay, so here's a common mistake question. The engineers might appreciate this. I show you the answer and a solution. So what I do is I put up which, for unit conversions, which one of the following choices is equivalent to 8 meters squared, and it's sort of different units. And this is a common error that students forget to, because it's centimeters squared. They know how many centimeters in a meter, but centimeters squared and meters squared, it's a common mistake. Now, so every discipline has their set of common mistakes. And if we tell them, hey, watch out for that, maybe 1 out of 100 will get that, okay. But now when I put up a question like this and, half the class gets it wrong or more, the correct answer was D, and 45% and 47. So it was basically split, 50-50 with a few that were out of the way. This was sort of a wake-up. I didn't do a feedback loop on this because I knew where this was going. This was just the sort of the, let me get this out of the way now.
The key is that it's a good wrong answer.
Right, it's the most common wrong answer.
But it's also the most reasonable wrong answer.
Fair enough.
It's not a factor. It's not that it's going to be squared. Others are like silly.
Sure, sure. Yeah, and
So that's somewhat
yes, that's right. And that they got the most common wrong answer.
Yeah.
But so here's a nice kind of question that so it starts to generate discussion or thinking, and then of course if you show this, if you re-vote, then it'll they'll say, oh, I found my factor. But this is a nice wake-up call, get them ready for their homework. So that was a neat question. Here was one with graphical communication. I described adding vectors. And there's the triangle. So the correct answer is these three in gray. It was C, D, and F. And we had just spent 2 days drawing these and going over these, and we had other questions. So I asked, which ones were the right ones. And again, so I got, I'm sorry if you can't read that, that's, I can't even read that. Yeah, that's right. So C, D, and they chose this one, even though these two arrows are pointing down and this one's pointing back, and they couldn't all be the same. Okay, and it happened. This was at the end of lecture. It turns out the last 5 minutes of lecture, their attention on the questions is not as strong as it should be. I added extra emphasis on this the next class period instead. So that's how I close the feedback here. But this is still, there's a few concepts in physics. The right-hand rule is another one where you can do it and it looks so simple and they shake their heads, but when they try and go draw it, it's a whole new challenge. And so this really, bringing this into the classroom forces them to internalize that. And I'm like, get out a piece of paper and draw your arrows. And so the next class, I'll just put the answers up. I gave them another arrow question, very similar. And so with repetition of this difficult skill, this graphical communication, their response is improved. So here was one class to the next, but very similar questions. So now they got it. And I think the active way of forcing them to participate in class, is waking them up, getting them ready. Where if I didn't do this, some would have gotten it and not, but we wouldn't have had this improvement. I think they've got this improvement going. Now here's one that I thought this was sort of an eye-opener for me. I asked about vector product. We can multiply two vectors, and there's two different ways to do it: the dot product and cross product. But we also call them the scalar and the vector product. And this was about the vector product, and I thought it should be very easy because the math is not hard. The two vectors must be parallel to each other. It was the right answer. We won't describe the math that goes into that. Okay, and the first time voted, I believe that 61% or something. So it was 60-30, right? And so a significant fraction didn't get it. I thought to myself, we've been doing this for all class period. What went wrong? So here I did the discussion again after the vote. I showed them the vote, and I said, these are the two answers, and so which comes down to parallel and perpendicular. Again, the two obvious mistakes. But why they were making the mistake was the eye-opener for me. But so after I displayed the results, we had the discussion, we had a second vote. There was still a holdover, but we managed to get an improvement. And if you go to that G factor, my G factor was 0.5, which was about the gain. I don't know if that means anything. I just wanted to figure out that G, right? So so we had this gain, but here was the neat thing. Here's more detail. All you need to know is there's two different formulas, and they just differ by a cosine and a sine. But here's the complicated thing. They each have two names. I can call this the scalar or the dot. I can call this the vector or the cross. And I thought that was helpful to give them two names. That's what confused them. They were still trying to figure out which name went with which, so they had four names. So it wasn't the math at all, which I thought was the issue. So during the revote, I'm going up and down. Something I thought was helpful by not only calling them by their formal name, the scalar and the vector product, call them by their nickname, the dot product and cross product. That, having four names for two things, flabbergasted them.
I don't know what's there. At least mine don't.
No, sure. We work on that too.
That word really, that's not something that everybody in algebra thought
Right, right. Well, I tell them that there's just, scalars and vectors are the, first two representations of tensors anyway, which are the generic object. Just so they know that there's even more out there, that it's not just one weird word, that there's lots, and this is the tip of the iceberg. Oh, wonderful, wonderful.
I have a question about how you do your discussion. So you do the rebos.
Right.
So do you guide it, or do you let them just discuss it amongst themselves and convince each other? Or do you actually play active role and kind of guide the discussion? Or how do you do that?
That's a good question. So I'm in 210. I walk up and down the aisles, and I will stop with a group of students, or they might call me over. What about this? So they'll ask me a question, and I'll guide them. I won't give them exactly the answer, but I'll say, think about it this way, or why don't you draw the circle and give you an arrow like this? Won't that help your thinking? And I do that, and it's easy because they work in groups, 6, 8, 10. So if I go up one side, I can have 4 or 5 conversations on the way up, and I've covered half the classroom, and then we can answer that question, and the next question I might go up the other side.
Can you tell them that say, okay, the 2 answers that got the most votes, one of those is the correct one,
Right, that's right. I did, yes, I did. For this situation, I did. For usually when you get the good questions where you split the class like that, yes.
Okay.
Right, and we say just these 2.
But you always cut out some of the answers before you revote.
Right, right. And I don't always revote, okay? If it's, like today, they did really well. I expected them to not do as well, but for projectile motion, they had it going on. They were 70, 80% of all class, so that was good. So here's my summary slide, so we'll have some time for discussion. So I've implemented this version of peer instruction in the large introductory physics lecture, so we've got this feedback mechanism and this active learning, and this education research has shown this approach leads to better performance on benchmark exams compared to our traditional approach. And the added benefit for me is the students get practice with conceptual problems in addition to numerical problems, which I think is an important skill. It helps tell the story, and I think they can carry that over into other classes. And there's also noted improvement in attendance, so they have to come, so that's maybe not fair, but their attitudes towards lectures seem to be improved. They like coming, and in fact, a benefit is now that I walk them down the aisles, and they're used to calling me over during this voting period, they ask questions during lecture. Okay, so I will get in a large lecture class. What did that mean? Could you say that again? Some things you don't always get. So it helps build a rapport with the students, and they're comfortable. And so that's where I think I've seen the student attitudes are improved. And so that's what I have to say today. Thank you for your attention. Sure.
I remember Mark Crawford having a focus, and I was telling you about afterwards, he said one day he was horrified. A guy came in and he had 4 clickers spaced out on the desk in front of him. Do you have that kind? I mean, first of all, I don't know whether it'd be more fault of cheating for other students, or that he doesn't understand that if you're going to cheat, you're trying not to get caught.
Right.
Yeah, that's really upsetting. But do you have that kind of problem where other people are clicking for other people? Or was that when you gave too much credit?
I did see that, but just once, and it was a few years ago. Someone had 2 clickers with them, and I took the clicker from them, and the student had to come get it back, who had given it to them. But it's rare, and I look, every now and then I remind myself to look up and down the rows. It's a larger classroom. It's a little difficult for me to police, but the classroom's pretty full. So I'm not saying it doesn't happen, but I think it's with the relaxed grading scheme, because they can miss a day. I tell the students, they're like, oh, I missed a day, I was sick, I didn't feel good, whatever, and I'm like, it doesn't matter. Missing one day is not going to affect your points as long as you have normal, regular participation.
Well, the point ought to be that doing this is not so much the 15% that you get, but that maybe you'll do better on time.
Sure.
So motivation to do it.
Right.
Building up the next semester, and to be a correlation between quicker scores.
Say that again? Yeah.
Does it correlate, do you think? Like, if students get all the quicker questions right, do they often do better on the exams as well? Or have you ever looked at that?
Well, I tried to look. I don't have data from my traditional lecture courses a few years ago on the same questions. I looked for that. What I can tell you is I think they do better on the conceptual problems that I put on the exams. It doesn't just fool everybody now when I have, true, false, or a diagram. I can now put those on comfortably. They still would rather memorize a formula. So I think that, but that's still anecdotal evidence. But that's the best I can give you right now. I think it's right, because I tell them, you see it in class, you see it in the homework. It can be on the exam because we've trained for it now. Right? Because they can only tell me what I've told them. Right? This is sort of the mode that they're used to. Right? They expect on the exam. They want to know what's going to be on the exam, and so it's not from left field. It's not, sudden, change of a question that they're used to answering. Yes, ma'am.
I might be wrong, but I was under the impression that you might have some clickers that you can use money at all. No.
You still have an extra box that somebody puts out there so they could check it out when you buy it.
Right. When I use the Wisdom clickers, I could do that. There is a way to loan clickers with the new system, but with a class of 240, it's a pain. So I just say, if you forget your clicker, you're in trouble. But again, one day is not going to hurt you as long as you continue to play the rest of the time, because otherwise, when it was a class of less than 100, and there was always 3, 4, 5 I was giving out every day because they knew that they were there. Oh, they just forgot them. Their batteries died. So now, and of these kind of clickers, I don't have anyway.
UPS doesn't have them to support them. There's some departments that provide them support for them. Right.
I did hear the students complaining in an elevator once about how they had to buy new clickers because the professor would buy a new system and it wouldn't recognize the old clickers. So like every semester or year they have to buy a new one and they have multiples. Have you run into anything students complaining about that?
No, I could see that early on. There's different vendors. I think we sort of converged at USC, not on purpose, to this iClicker. And like I said, we used this other manufacturer for several years, and then I would only ask the students to buy it if they were doing a two-class sequence with me, because that was $40, $50 for that little red clicker. And so I was happy to switch, and the software is better for iClicker here. It's easier to use and it's less crash prone. But then there's this terrific used market now, which is great. So I don't feel guilty at all. They can get them for $10, and they come up with these beat up clickers, but they work fine. And so that used to be a problem.
I guess with the new version, because one of them you can actually type in answers instead of multiple choice.
Sure.
It depends a little bit on what kind of questions you want to ask.
Right, that's right. Yes, and I keep my questions to A, B, C, D, E. So. Because I want them to be able to use the old clickers because they're cheap. Although the manufacturer gave me the nice new clickers. They're fancy, they're pretty, but.
So how does the display work? Do you put, like, if you're showing slides, do you put it in as like sort of a plug-in or something that comes in there to get the collect the response?
No, you don't have to do that with this system, which is great. Whenever you start a question, it'll take a screenshot of what's ever on the screen. So it's not attached to any particular program.
It's running in the background, basically.
Right, and so.
Have a little window that sort of sits for the Windows PC side. It has a little window sitting there all
Yeah,
the time.
yeah. It has a little tiny bar, menu bar, and I make mine small. But when you turn on the question, it shows how many people. It shows a timer, how long the question is on, and how many people have answered, up on the screen. So I watch that, and I say, okay, in 15 seconds, we've got to have everybody in or whatever, and they'll put them in. I'm gonna.
On the button you push to make the graphs come up.
Yes, right. So on your remote, you have a start and stop question and show results, and then.
So how do they see it on the PowerPoint?
See what?
I see the little bar, and when you start the questioning, it changes the bar to a little bit bigger bar with how many people are responding to the
So
clock.
essentially, as long as your computer set up that it's projecting the display and the computer is able to see that. But it doesn't say anything about the right answer on that.
No,
have to
no.
toggle the graph on.
Yeah, you could
You
turn.
toggle the graph on while they're still answering, so they can switch their answers if they want.
Yeah, I've done that. When I did the revote, one of the first revotes this semester, and they see the bigger bar, and you see it changing as soon as they see other response. So now I cut it off, and then discuss and revote and turn it on. Yeah, yeah. Actually, another one of our professors, Joe Johnson, is doing this with these smart systems. This sort of crowdsourcing, trying to see if the crowd can come up with the right answer and this kind of idea. But stay away from that.
But it's almost like trivia night. You could put that up and give them hints to see if they switch over to.
Right. Yeah.
They can switch their answers whenever they want to.
Right. So this is the.
Switching just because other people are doing it is a different thing than.
Right. Yeah.
Did you say you were tied into Blackboard to automatically populate grades?
No, I haven't done it this year. So I'll just take the Excel spreadsheet out of the clickers and populate the Blackboard spreadsheet and send it up. But there's a way to now register your clicker through Blackboard, which is new this year.
There's also a way to automatically put the grades straight in the Blackboard.
Oh, is there?
At least one of my colleagues keeps bugging me, wants me to figure it out for them.
Oh, see. But I like to look at the grades and massage them the way I want and give them an aggregate grade instead of having them have their own all this raw data. So I need to look at that myself. I'm glad Blackboard is evolving. I know the students like it, and I use it when I can. But
the iGrader program is pretty good. I mean, you can do a lot with the data that you get from the answer. You can set each answer for fractions and points, things like that, depending on the grading scheme. So there's some advantages, I think, of using that first, and then, like you said, just loading a final score from Blackboard.
Right, because since I do this funky 70% and the attendance points, and I kind of keep them separate, and then I can look at their attendance, and I have all this.
Sort of done by decoding this connected through and gotten all your filter points and codes, right? It's really smart.
I suppose.
I've tried this a couple of semesters now, and we don't have lots of great questions to draw from. So there's little tricks you eventually pick up, like determinant matrix is less than 0, greater than 0, equal to 0. How to come up with multiple choice questions when you traditionally haven't done it that way, I thought was challenging at first, but eventually we can work it out.
Well, I like the idea of the concept questions, and I think I'm going to steal that idea. What I try to do is put open-ended questions. Well, there's a limited number of open-ended questions, and like I have one that I say, if you could invent a numerical method instead of Newton's method when the derivative is too hard, and what I want them to do is say, oh, I'll approximate the derivative by size of the run sort of a thing. And they want practice questions like that. Well, there aren't a lot. You know, the whole point is, can you answer a question that you haven't practiced on?
Right,
and,
right.
But concepts, that's still quasi open-ended.
Yeah.
I do a lot of the graphical stuff. Everything I do, I say you can draw, you can remember it, like what you can look at on it. They don't read the book, and they can do it anyway.
Right. So this is a way to get them. You know what else I use too? The checkpoints in the textbook. I don't know if the physics books have these, after sections they'll have a little conceptual question, a checkpoint, and it's usually an A, B, C, D, or rank the 3 little situations, 4 situations. You can turn those into these kind of clicker questions, and I do that because then I say, this question, if you did your reading, that was there, or the conceptual questions at the end of the chapter before the numerical ones. They have, you can see a lot of times they'll have rank the situations or some multiple choice, which of these situations is the right one. Right. Yeah, so you can take those right out of the book. And I think that's, so we're not changing the material so much. It's just an effective use of those conceptual questions at the back of the book.
I don't have those, but I can make some up.
Oh, okay. Yes, sir.
mentioned,
I'm sorry, you had a question.
you mentioned opinion questions, opinion polling to get people engaged. That's something Rich Felder always tells us, let them give you feedback so that they don't unleash at the end of the semester on the student eval. So if you're always getting feedback, they have less to complain about. So I use that, what topic do we need to review for? What do you not like about, here's some things that you're not happy with. What should I try and improve? And I've also put in a couple of fun questions here and there, so if you like to even the $40 iClicker a little more, like some picture of an old guy with steer rack or maybe cider or fly, see what the old guy is. And silly stuff doesn't take much time, but it gets them a little bit engaged too.
Yeah.
I'm just curious, is that conceptual media done better, but have you done reflecting on your own teaching? Do you have own students acting? Do you have own students acting with A? Have you looked at your own data just to see? I mean, this could be a great publication.
Yes. I don't have enough systematic data to answer those questions. I started, for this talk, started looking at that sort of thing. But I mean, this is, my colleagues and I, we've discussed this. We could do. There's a bunch of studies I'd like to do. I mean, I'd like to take out of this 250-person class, take 40 or 50, and instead of recitation, put them in a quiet room and let them read the book, and just compare their performance to the norm, or these sort of things. But yes, that's why I said this is best practices. It's been proven in other universities, and I see some, improvement here, but it's anecdotal.
May I ask you something?
Please.
Do you share your data with the TAs? So you would know which student is constantly missing. I mean, I looked at your data, and so it went through the 140 out of 240, but then there were always the 20, 30. I mean, that's 10% of it. So do you share that information with the TAs, so the TAs can maybe work with those students?
Well, I'm the TA. Physics is not a large department, so that.
So you do all of them.
Yes, but you're right. You see the correlations, and so in my spreadsheet, this is just one piece. So you have the attendance and the clickers, and you can see their homework and their tests, and the homework, how much they do in the homework generally correlates with this as well. So yes, you can see that.
I think the strength of it is a lot of what they've been talking about is add technology, add what these kids are used to in terms of the online things, and that they are very used to small enough information and switching around. And I think if you break up on that kid, then in terms of the lexicon, they're listening, where there's a consequence. You have to stop and change format, or they don't know how to follow it. They're used to Facebook and Twitter and this and that and that. Maybe they're not learning anything from all that Switzerland, but that's a format that they're a little more used to. So it's like offering a movie in a class or things like that. It's just it breaks that. They don't have long attention spans, so you have to sort of fool with that so that they restart their attention span clock several times during the class.
Get them re-engaged.
Yeah, and this clicker part, I think, is moderately.
It is, and again, the key though is to get the right style question where it gets them thinking, and it's not too easy or not too hard, and where you can maybe have that most common wrong answer and split the class and get the dynamic going, and so we that. Right, and and so we have the luxury of different libraries to pick and choose, and now I make my own now that I've been doing it a few years, but still the textbook is full of them for us, and I think that's the key is having the right kind of question. But then but that's not the clicker. That's like any good class. If you have a class of 3, 4, if you have the right question that sparks a discussion, you're doing a good job teaching, and this is just a mechanism to bring that idea into this large lecture. It'd be best if we could have, instead of one class with 240, have 10 or 15 in a class, and give them more personal attention. But
if you did it, if you used to, they've always had these generic questions. What do you think would happen here if I did this? And you get 1 or 2 people that volunteer, and like everyone else is reading newspapers. And with the clicker, you can ask that kind of question. Everyone has to think about it. That's the big difference. And I think there's so many really good conceptual questions. What do you think will happen here? What do you think will happen next? But you can't put on an exam, put homework effectively. the program out in the lecture.
Right. Right.
If you get 3 or 4 people that routinely respond, you can think that's a great chance.
Right, right. And I guess I would use this in a class of 20 now. Again, it's just a great sort of mechanism.
I started out in a lecture class about 15 years ago. Get used to the mechanism of doing it.
And the lecturing is a little bit different, you know, because you have to put in these slides, these questions, and it's 3-4 minutes per slide or per question plus answer. And if you do 3 or 4 of those, you know, that's 15, 20 minutes. Yeah, a third of your lecture is gone. So you need to somehow make up that missed ground with the slides themselves, so that you know it can't just be a check on what you taught. You have to sort of somehow.
You don't, it's not so much you have to make it up and down, because it's probably possible that if you didn't cover it in the quicker, you have to repeat it again the next lecture. So
That's right.
I don't think it's a waste of time.
No, no, it's not. Yeah, I agree.
Less is more. We're approaching our hour, so we should
Okay.
let people go. If you want to stick around and ask more questions. Thank you very much, guys.
All right. Thank you.